Hello everyone, welcome back to my channel. Let's write up the solution for min stack. So first thing we're gonna do is to create a node class. So we can do public class node, and we can decide what data fields we're gonna have. We want to do all the operation at constant time, so we can have value variable, and we can also have node next variable, which point to the next node in the stack or the one below the current node. And we're also going to have a minimum variable, which represents the minimum variable in the stack only when the current node is at the top of the stack. And then we can have a constructor, so public node, and we can just initialize all these data fields. So we can do int v, node n, int m, initialize the variables here. So next would be n, and min would be m. And then we can have a head pointer, which will point to the top of the stack at all times. You can declare the head pointer here. When the min stack constructor is invoked, we can initialize the head pointer, which will point to null because the stack is empty. It has no value. Okay, so let's work on the push operation. So for push operation, every time we're going to create a new node and we add it to the stack, we're going to have two options, two different ways to do this. And we're going to check if the stack is empty, and if it is empty, we're going to do one operation. If it's not empty, we're going to do another. So we can check if the stack is empty by checking the head. So if head is pointing to null, then the stack is empty. And if it points to some other value, then it's not empty. So if it's empty, then we're gonna create a new node. And again, we'll have three arguments for the constructor. First one was value, so we're gonna add the given value here. And the next pointer will point to null because there's no other element in the stack. This is the first one. And the minimum value is also going to be the value of the new node because it's the only value in the stack. And then we're going to update the head pointer, and head pointer will be at the new node. And next, if the stack is not empty, then we're also going to create a new node, and the value will also be the given value. But the next pointer will point to the current head, which is the one below, which would be the one below the new head. And the minimum value will be either current head's minimum value or the current value that we're adding. So we can do that by math.min. So we want to have whichever is smaller. So we're gonna have the head's minimum value or current value that we are adding. And we can update the head, and head will point to the new node. After that, it will be very, very simple. We are going to do the pop operation. So the pop operation, we are just going to remove the node at the top of the stack. So to do that, we only have to move the head pointer to the next one. By doing so, we no longer have access to the previous head node. And the top operation is also very simple. We're just going to return the value at the head. So we can just do return head.val. well, actually it's value in this case. Okay, and the getMin operation is also very simple. We can just return the minimum variable or min variable at the head of the stack. So we can just do return head.min. And again, the minimum or min variable represents the minimum number in the stack when this node is at the top of the stack. Let's see if this works. Okay, so this was min stack. Thank you for watching. If you'd like to see the detailed explanation of this problem, click on this next video or click the link in the description.